So yeah, Professor, it was, and it is, and it will be for the future. An absolute pleasure to have the opportunity to have you with us early today. Your way of thinking is so young and so disruptive that you are indeed an inspiration for all of us. And we made an evaluation together with the Q&A audience, and the majority of the answer was that your session was indeed inspirational. So thank you so much for your availability, and I'm pretty sure that we'll stay in touch.
Thank you, thank
Okay,
you, thank you,
thank you,
everybody.
thank you very much. Okay, so I don't know about everybody else, but I think that we had a fantastic first session, and the evaluation that you did of the keynote is exactly in my opinion. And when we talk about opinion, we will talk now about one tweet, one single tweet that disrupted a full value chain. One simple RT that fostered cooperative innovation and brought the best of people and engineers when in the face of a challenge. So João Nascimento had this vision, grabbed his mobile phone, and Twitter gave it a stage. So I would like to welcome João and Professor Paulo. I'll start by introducing Professor Paulo. So Professor Paulo has a degree in technological physics engineering from Instituto Superior Técnico in Portugal and a PhD in physics radiation. And João is an entrepreneur that is currently studying neuroscience and philosophy in Harvard University, and both of them founded the Open Air project, which responds for the needs on the COVID-19 pandemic regarding to the lack of ventilators. So good morning to both of you. I think you are listening to me, right?
Yep, all good.
Awesome. Good morning, João. And the stage is yours.
Thank you very much. Thank you for the invitation. It's great to be here with such brilliant speakers and panelists. It's really good. It's a great Saturday morning. Sorry if my voice today seems like I'm in a long distance call. So it's just a little bit of allergies, not COVID-19. So we're good on that pattern. So today I'm here to speak about the Project Open Air, how this project started, how is still ongoing, and how did we manage to get a lot of brilliant people together. And so I'll start by sharing probably my screen on my notes, which is, let me see. This is probably some of the most spoken words in 2020, which are, can you see my screen?
Yes, perfectly.
Perfect. There you go. Okay. All good. I think you can see it. Anyway, here we go. So Project Open Air numbers. We've been running for 6 months now. We divided in 4 main projects. We had volunteers from 34 countries. The 1,600 volunteers, it's actually not very accurate. There was a time that we had around 5,000, but we started only counting the ones that were actually in projects or interacting in some way. So the 5,000 were people who were actually trying to give some help, send their emails, get in the Slack channel. But the 1,600 volunteers were the volunteers that actually had some sort of engagement. The 5,000 protection kits, it's an output of one of the projects that's already produced and delivered. And this is what Hugo was talking about, how it all started with a tweet. So in a time that it's a hot topic, social media, this is probably a good example how social media can be used for good. I think of social media as a tool, the same way as you can think of, let's say a knife. With a knife, you can use it to cut vegetables and make a soup, or you can use a knife to harm people. So social media is it's pretty much the same. Of course, not all social media is the same. Some might have some practices that are not so clear, but the principle, I think it's the same. We can use it for good. We can use it to gather people around a project, an idea, and so that's why we're here today. This all started with this tweet. It was on March 11, 2020, and then it got retweeted by thousands of people, and here we are. So on the first day, I encountered 2 or 3 people talking about open source ventilators. And this all started because I was seeing the news, as most of you were on the north of Italy, was seeing that people were lacking ventilators because the supply chain was completely disrupted. And so we start thinking of applying first principles. What is that machine? How is it built? And when I went online, search on Twitter, found 2 or 3 people talking about open source ventilators. And I say, well, we should team up, and try to find somebody who knows how to do this stuff, because I have no idea how to do it. And here we are. And so at the end of the day, we were 7 people on a Slack channel. Next day, we were 500 people. And then the media picked up the story and it went completely berserk. Following days, there we go. We were on Reuters, Wall Street Journal, NASDAQ, New York Times. We were on the national Portuguese TV, and which was quite key to gather the support of companies, of universities. And I can't stress enough the importance of the engagement between academia and media, or at least a sort of putting out there the idea, putting out there what you're trying to achieve, because otherwise it would be impossible to gather all the support that we had, all the means, because on the first week it was completely madness. We were just trying to organize everybody around the projects, but after we had that madness, I was contacted by local authorities, local universities, local companies that can actually put you in contact with the right people, can give you the access to the materials, to the labs, when you can develop and some ideas and going forward on projects. So it is extremely important, this marriage between the ideas and the way to put it out there, because otherwise you could have the best intentions in the world, the best ideas in the world, but if nobody knows what you're doing, it's a little bit complicated. That's why we had, like, for example, TAP. It was on 2 or 3 days, at least for a week. TAP is the Portuguese hair carrier, the TAP Air Portugal. We had their maintenance department working with us on fixing old ventilators and giving them back to the hospitals. This is insane. Just think about it, to have one of the largest airlines carriers in the world, to have all the maintenance working with us. So this would be impossible if you don't have the media exposition, the engagement. So we divided Project Open Air between 4 main projects: the open source ventilator, which it all started with the open source ventilator. Then we had the Masks for All, which was researching and searching for better ways to go on social masks. We had VentuLife, which is a platform that I'll go through in a minute, and the Frontline Medic Protection Kit, the reusable kits for the protective gear of medicals. The VentuLife, the platform, this was actually the first project that came out of the production line, if we can call it like that, which is pretty much a platform that put in contact hospitals and academia, volunteers, engineers around the world. Who can actually give them a hand in repairing old ventilators, old machines that have some problems. Sometimes it's not very complicated issues that can be 3D printed, that can be remotely fixed, and we put online this platform with the help of OutSystems and hundreds of volunteers, amazing people that were working almost 24/7 for a couple of days. It was a very interesting project, and it's out there, it's live. We have a Portuguese, Spanish, English version. And we have been contacted by some industries around the world who were quite interested in the concept, in the idea. Then we had the masks for all with the research and development of reusable masks. We played together a little bit with these materials. There were some fires, as far as I'm aware, when we tried to microwave some masks, in the idea with having some material that could be easily or in a way we could clean but without water, so we could actually clean the virus without the water. So that's why we were toying with the microwaves. And then we had the frontline medic protection, which it's currently undergoing. It's washable at 60 degrees, reusable until 25 times. It actually can be more than 25 times, but we have the certification for at least 25 times. And so that's where we're going. We're currently in a production of another batch of those suits, eventually to be delivered to other hospitals and to other institutions that contact us and show their interest in having this reusable kits in spite of the other disposable ones, which can be quite expensive for the hospitals and for the institutions. And then we had the open source ventilator, which Professor Paulo Fonte will speak you more in detail. It was a fantastic group that was put together and who did deliver an open source ventilator, which is published, it's out there. And if we can at least have some conclusion and some outcome of this project, is that 2 or 3 things. But first is when you ask for help, people might actually help you. So it doesn't cost ask for help. It's what's the worst they can do, people say no. So this was the whole premise of Project Open Air since the beginning. It was, let's ask help from people who actually know what they're talking about, and eventually we can get some help. The second is social media can be used for good. And the third is when you get this amount of brain power, you get really spoiled, because then you get a lot of very interesting ideas, very cool ideas. And if you want to try it out, you have the best people in the industry working with you. So we had Formula One engineers, we had people from academia, we had people from airlines companies. So you can pretty much do everything, which is not like that, of course, in the real world, because it will cost a lot of money to have all this brain power at your disposal almost 24/7. But we try to do our best with all these resources. In June 2020, we donated all the projects to Médecins do Mundo, Doctors of the World, Médicos do Mundo in Portugal, because we thought it was the natural conclusion of the project. We didn't start this to be a company. We didn't start this to be a product. We didn't start this at all to perpetuate ourselves. We started this to solve a problem. Eventually, we tried to solve 3 more problems. We tried to be useful. And once we got the MVP, the minimal viable products on these 4 areas, we thought, well, okay, what is the best way to deliver, to actually reach the front line, to actually reach the people who need it? And the best people to do that were exactly the ONGs who had the experience in the front line, in the field, like Doctors of the World. So that's why we donated everything to Doctors of the World. We are cooperating with them. They are an amazing organization. I strongly advise everyone to volunteer, because they do an amazing work. And that was it. It was a fantastic project. It was 6 months that I will probably never forget about the rest of my life. And here we are. I hope that if for not anything, this was an inspiring experience, that when we got together and we work together, we can sometimes achieve interesting outcomes. So that it is. I hope, yeah, it's working. I'll stop sharing my screen. And I think And now I will deliver to Paulo the stage, right? I think you're muted.
Exactly, you're muted, Paulo.
Okay.
No, not yet. So it's traditional traditional slight technical struggle with the audio, but until now we are not listening to you. No, not yet. Well, in the meantime, João, I'll be asking you some early questions. So,
sure.
How can you manage? How did you manage in the first weeks consolidating and talking with so much people at the same time?
Hello, can you hear me?
Okay, awesome. Now okay. Sorry, João. So we'll start later. Okay, go ahead, Paulo. Thank you.
Okay, so let me share my slides. So can you?
Yes, everyone is seeing. Yeah, perfectly.
Okay, so these were like very interesting times, as you can imagine, very hectic. As João mentioned, we put together a very fantastic team composed by chemists, engineers, physicians, physicists, and technicians. Out of curiosity, actually, there are two mechanical engineers that work currently for Formula One teams, Pedro Sousa and Gonçalo Pimenta. And I think one important or fundamental characteristic of this team was that we had physicians on the team, and we could interact with them, and we could find a compromise, an intersection between the instrumental difficulties and the medical requirements. And we tried to find a common ground between these two, of course, contradictory requirements. And well, I believe we found it. Okay, so this team produced 3 prototypes, one called Minivent. This was mostly the work of people from University Nova de Lisboa. And then in Coimbra, we produced 2 prototypes. We called the 11th of April because it was ready to be produced on this date. And on this, there is an archive preprint where, faithful to the open source concept, we published everything, the schematics, the mechanical drawing, etc. And then more recently, we developed a derivative model called Even, much more compact, much more user-friendly. And I'll talk a little bit about that as well. It's very important to understand our work. It is very important to understand the constraints of the time and the environment. So this is a timeline of our development superimposed on the casualty curve in Portugal. We started in the end of March. We had a meeting on a Sunday where we exactly discussed with the physicians what are the needs, what are the difficulties, etc. And then a little bit later, we had a proof of concept over a table. That's what João has shown. This is not what he has shown is a proof of concept. It was made with tubes made for sprinklers. And then about a week later, we had this 11th of April prototype ready. And this coincided with the peak of the pandemic in Portugal. A little bit later, we published this preprint. About a week later, we made some chemical and bacteriological tests in between. Okay, and then at this time, we already knew it would not be needed because, of course, the peak had passed. The infection rate was already decreasing. But anyhow, we continued to work in the hope that this could be useful elsewhere particularly in countries with, let's say, less resources than we have here in Europe. So I would summarize that to say that the goal was to design an emergency ventilator relevant for the handling of the pandemic. Relevant is a very important word. I'll come back to that later. And constructible in times of logistic shortage or disruption, or in areas with reduced access to technical materials and at a moderate cost, affordable to lower income countries. And so the constraints are very important to also to understand what we need. And the constraints were poor access to technical components via international trade. For instance, at that time, we ordered a flow meter, a simple industrial flow meter from Germany, and it took 3 weeks to arrive. So it would be impossible to build, well, one ventilator we could maybe build, but here comes in view the word relevant. So to be relevant is not to build one and leave to others the responsibility to replicate it. To be relevant is to actually do something which could be reproduced in the hundreds or thousands, to be, let's say, to have a measurable impact in the healthcare capability. And for this, we had to restrict ourselves to components, to technical components that we could find, let's say, in stock in Portugal. And this also applies to other countries, for instance, in Africa, where, of course, their access to technical materials is, at these times, very limited. And of course, the urgency was extreme. So our technical solution was dictated by these three constraints. So we came up with this. Okay, there is a supply of oxygen and air. The pressures are regulated directly to the pressure that is needed for the patient inspiration, called PIP pressure. And these regulators, you can see here are these blue devices. These regulators are used normally for gas distribution in buildings. Of course, these are not medical devices, but we made chemical and bacteriological tests and found them to be without any problem, very clean. And let's not undervalue them, because these have been around for 70 years. They benefit from 70 years of industrial development, and they are actually very robust, and they regulate very accurately by turning this internal screw. And then we used also electrovalves for the same application, normal use for the same application. And for other, so when the electrovalve opens, the patient, the inspiration tube is pressurized, and this is supplied to the patient. The lungs are inflated, and then after a certain time, which is programmable, the expiration valve opens, the lungs deflate, and we need a back pressure valve to keep some residual pressure in the lungs, called the PIP pressure. And this is important to keep the alveoli open all the time, as far as I could understand. And for these components, we use water columns. Water columns, anyone can do. They are very safe, very reliable. There is no development time involved. So we use water columns for the back pressure valve, and also for a safety valve to make it impossible to apply a dangerous overpressure to the patient. Also, the pressure measurement can be done by a manometer, mechanical manometer. Again, we had extreme difficulties in finding these manometers in quantity. So we, in parallel with this mechanical manometer, we put a U-tube water manometer, which measures by definition in centimeters of water. It's mechanical, but just by using a scale. So it cannot be wrong. It's also quite accurate. And this way we could do the full ventilator with materials we had in quantity in stock. There is some electronics. There is no feedback electronics. It's exclusively feed forward. So there is really nothing complicated to fail. Everything is quite simple. And people who knows electronics will find out that this is extremely simple and made with very common components like the 555 timer, the TL331 comparator regulators. So it may look complicated, but it is not. Also, there is apnea and power loss alarm, which will sound if somehow the pressure wave is missing, if there is no pressure variations in the inspiration tube, and also if the power is lost, then there will be an alarm sounding. So a view of the device in action. You can see here, this is the model lung, the expiration PIP valve. There is external oximeter, which measures the fraction of oxygen, and here the water manometer, which oscillates up and down, measuring the pressure. You can see here that this little blue column going up and down. The scale is missing, but in the final version there was a scale to measure the difference in height. So these are some technical details which I don't have time to go on it. These are the safety tests. For instance, this is a gas chromatogram of the oxygen flow through the inspiratory tube. And you can see that the sample is actually cleaner than the baseline because this was made in the hospital and there was probably some residual in the tubes which was cleaned first. So the baseline actually has some more peaks than the sample itself, but the sample is absolutely clean. So these devices, even if they are not made for medical applications, they don't pose any chemical threat to the health or bacteriological. We accumulated so far about 4.5 months of operation in pure oxygen and 4 months in air. This is still ongoing. And we had expressions of interest from people in Angola, Brazil, Ecuador, Ethiopia, Malawi, Mozambique, Haiti, and Uruguay. However, to our knowledge, it hasn't been deployed anywhere. And you can see here, this is the prototype made in an institute in Rio de Janeiro, Brazil. Now, our interest has shifted. Project Open Air has joined with Doctors of the World, and now for their in direction of their interests, well, it is clear right now that I think there won't be a shortage of ventilators, at least in Portugal. So I don't think we will. It's interesting to persist in that direction. But so we try to do for Doctors of the World, or in collaboration with Doctors of the World, something which I would describe as an all-terrain ventilator, something simple, robust, that can be maintained locally. Actually, these, I think the local car mechanic can repair with simple parts that can be provided or even found locally. And we introduced another mode of operation in which the patient can control the ventilator. So I don't have time to go to the details. I am already exceeding my 10 minutes, right?
Yes, a little bit. So if you can just wrap up 2 to 3 minutes, that would be awesome. Thank you.
So this is the general view of the device. It's more or less the same, but differently packed. And we replaced these very large water columns by mechanical valves that we developed, but it took us 3 weeks. So we could not, to respond to the pandemic, we could not invest 3 weeks in developing some valves, but now we did. So this is how they look like, and here is the PIP valve, which is inside this box. All these can be disassembled for sterilization, the expiration branch, I mean. And I'm not going to any details, and let's just show you the even ventilator at work. The yellow light is the pressure, the inspiration pressure, and the green light is the acknowledgement of the wave pressure. And if the green light doesn't blink, So if the green light doesn't blink after 15 seconds, there will be an alarm. Okay, so thank you very much for your interest.
Thank you, Paulo. Thank you, João. So fantastic project. I'll embrace it like this. This is for me one of the most brilliant projects that I've witnessed since I remember to be a human being, and this is absolutely marvelous initiative. And then, as João said, just a simple tweet put everyone in the world all together, all focused on tackling this pandemic in a collaborative environment. So I'll start off with a question for you, Paulo, which is, since the inception until now, what was the biggest struggle that the team faced in developing technically the ventilators?
Okay, the biggest problem it is
or the biggest challenge.
The biggest challenge is the regulatory process.
The regulatory process.
And then we are still struggling with that. It's a lot of work, and we have to do, for instance, animal tests, which we still could not find the right collaborators to do this. We had a false start, apparently. So yes, this is the most complicated and of very uncertain outcome.
Very well. With regards with this new connection with the doctors of the world, how do you foresee this project evolve and future projects that may start from this relationship?
This is for you, João.
It can be for both.
I guess it will depend. I guess it will depend on the missions of the world. They have shown a lot of interest in this even concept of ventilators, exactly because it can be used in remote locations and can be assisted in remote locations. And they also shared the idea of eventually on a later stage, as soon as everything is certified and everything is ready to use, to share with other ONGs that can actually use this device. So eventually can be an interesting outcome, but we're still on the early stages of it.
Yeah. So I'll get back now for my initial question to you. So massive response in the beginning. So a lot of people coming in. How did you filter this information? How did you manage all of this? What can you tell us on coordinating 5,000 people knocking on the door and saying, "Look, I want to help"?
Complicated. I had a lot of help. It's to put it simply, I had a lot of help. It was a task way too big to handle alone. So we started to implement as soon as possible some stage of organization in people. Then we got the help of McKinsey in helping and designing teams. Then we got Microsoft giving us tools that also helped a lot in managing teams and give them tools. We had a lot of help. It's the only way possible, because it's pretty much setting up the structure of a small, medium company in a week, at least.
Yeah, very well. So I'll open the stage for the Q&A. We already have some questions. So I think the first question is for Professor Paulo. So you mentioned the stock of components, and the question is regarding whether the stock of components available is directly or sticked to the budgeting of the project itself.
No, there is not a direct relation between budget and availability, because these are common industrial components. So the full price of these, actually the most expensive surprisingly, the most expensive item was the water columns.
The water columns, really.
And these, for instance, these regulators cost 20 euros, maybe. The electro valves 40. So it's not a problem of budget; it's a problem of availability.
Very well. We have another question, I think, maybe for both, for João and Paulo, from Sara Francisco, that says that there were certified ventilators available by medtech companies announced in the media, and our question is regarding the reasons for the development of a new ventilator.
Well, Paul, if you want to.
No, in April, there was not. In April, there was a worldwide fight, a worldwide dirty fight for ventilators. So
and I can absolutely subscribe to Paulo, and I can confirm that we were in talk with some authorities that in the middle of the night, to give you an example, there were ventilators that were being sneaked by other countries. They were paying more. There was such a lack and such a race on ventilators that we had that, for an example, we had to charge 5,000 ventilators for Portugal at 2 a.m. and at 4 a.m. Canada got in and bid over us, and no ventilators for Portugal. So this is where we were. We were at the bid wars, no ventilators.
No ventilators. Okay, very well. A question here about the certification process. So people are asking, how are you managing to go through it, and if you have experts working with you in the team that can support you?
Yes, one of our partners is called ICNAS, is an institute from the University of Coimbra. Actually, they produce radiopharmaceuticals for PET, and they also have a department on animal tests, and they are used to these certification processes. So yes, their staff is managing this certification process. But as I said, this has been the most difficult, and we are not there yet.
Okay. Very well. So we have time for another question, and it will be from a team member as well. So Tiago, go ahead.
All right, thank you, Hugo. So my question is, I was writing this question in the chat for the lecturers because I don't know if we would have time to entertain this. But so we saw that this pandemic outbreak provided, or let's say, motivated the need for people to the will of help for people. So basically, we saw lots of volunteers, saw lots of open source projects. Do you believe that the resolution of this pandemic outbreak will cool down this will to do things? Because when we have these needs, so this problem, people are willing to help, but then when things are quite stable again, so will the paradigm change, or we are facing a new paradigm even for medical industry, this connection between academia and the open source, which is getting quite trendy nowadays? So how do you think that things will go from now on?
In my opinion, if I can start, and then Paulo can share his opinion, eventually it will be a bit of both. Of course, there's always the natural reaction of going back to the way things were once things get a bit calmer. I think it's just natural. But there are steps that were already taken. There were connections made. There were developments that were achieved that I don't think they will be reversed. So I think it would be a little bit of both. In a way, there was actually, and you're right, there was a change a shift in the way that things were done. I wouldn't say it's a complete change of the paradigm of how we will behave as an industry, but eventually there will be some disruption. Eventually there will be some outcomes, and we're already seeing that there are already some results, some very interesting outcomes coming from this pandemic. So I think the right question, if there's any, it's somewhere in between.
Very well. So we don't have more questions from the audience. I don't have also more questions for you both. I just want to acknowledge and truly say that both of you, and especially I apologize, Professor Paulo, but João took the lead with the tweet. So João, an absolute inspiration for everyone, and to show to the world that we can actually lead innovation, cooperative innovation, and be successful working all together. So I want to thank you for being here, and we are a little behind schedule, so I would say that we have now a 10 minutes break, and then we'll restart at 11:30 for the second part of FIB. Okay, so we'll be back in 10 minutes. Okay, see you then.
Thank you. Bye bye.
Thank you, Paulo. Thank you, João.
Cheers. Bye bye.